A rhythmic gymnast releases a hoop. It rolls across the floor, moving away from her hand. Then, almost as if it changed its mind, the hoop slows down, stops, and returns. It looks like a trick, but the hoop is not being pulled by a string. It is obeying friction. A gymnastics hoop has two kinds of motion at the same time. First, its center moves across the floor. This is translational motion. Second, the hoop spins around its own center. This is rotational motion. Those two motions do not always agree. If a wheel rolls normally, the bottom point of the wheel is momentarily at rest against the ground. There is no slipping. The wheel's forward speed and spin match each other. But a gymnast can throw the hoop forward while giving it the wrong kind of spin. The hoop moves away, but it carries backspin. At the contact point with the floor, the surface of the hoop is trying to slide forward. The floor resists that sliding. Friction acts backward. That backward friction slows the hoop's forward motion. At the same time, friction also changes the hoop's spin. If the backspin is strong enough, the hoop's center keeps slowing until its forward motion becomes zero. But the hoop may still be spinning. Then friction keeps acting in the same general direction, and the center begins to move backward. Now the hoop returns toward the gymnast. This is the same family of physics that makes a backspinning ball behave strangely after it hits the ground. Spin changes the way friction acts. Friction changes motion. The result can look almost alive. But the return is not guaranteed. If the hoop is thrown too fast, the forward motion wins. The hoop keeps going away. If it is given too little spin, it may slow down but not come back. If the spin is too strong and the forward speed too small, it may return too early. The beautiful part of the performance is that the athlete controls both speeds at once, the speed of the hoop's center and the angular speed of the hoop's rotation. A common misconception is that the hoop returns because circular objects naturally come back. They do not. A hoop rolling without special spin simply rolls forward until resistance slows it down. The return happens only when the gymnast creates the right mismatch between translation and rotation. Forward motion says, go away. Backspin says, come back. Friction decides which one wins. So the returning hoop is not magic. It is a moving physics experiment built from three things: spin, slipping, and friction. The gymnast's skill is to hide the calculation inside one elegant throw.